All right, well, let's get started, everybody. So once again, I'm Ray DiGiacomo from the Orange County R user group. We're going to talk about the PMML Transformations package today. We have Tridivesh Jaina here, the package maintainer for PMML Transformations, and he also works on the PMML core package as well. Before we get started, I just wanted to talk about the GoToWebinar control panel. And you'll notice that you have an orange button on your GoToWebinar control panel. And this will allow you to maximize and minimize your control panel. And when it's maximized, you can select your audio type. Most people are going to use microphone and speakers mode. You can also use telephone mode, but the popular method is microphone and speakers mode. And try to close other applications you might have open that might take bandwidth, things like Skype, LinkedIn, Facebook, Twitter, etc. And then you can make the webinar full screen to see the screen as large as possible. And then you can use headphones as well if you have them. You don't really need to use headphones, but if you have some iPod earbuds on your desk, you may want to plug them in. It'll allow you to hear our voices better. And then you'll notice this red circle here. If you have a question during the webinar, go ahead and submit it through this question pane. And then we're going to have a Q&A session, and the presenters will answer your questions. So this is the GoToWebinar control panel. I'm just going to do one slide on myself. So I'm Ray DiGiacomo, Jr., President of the Orange County R user group. I'm a Master R trainer and a healthcare predictive analytics consultant. If you're interested in joining the Orange County R user group, you can find us on LinkedIn groups, and then you can follow a short registration process. So that is it for my introduction. And now I'm going to go ahead and make Tridivesh Jaina the presenter. And so Tridivesh, go ahead and show your screen when you're ready.
Okay, hello. Let's see, show my. All right. I hope you can.
I can see your screen. PowerPoints are in full screen mode. So go ahead and introduce yourself, and then get comfortable. And you got the floor here.
All right. Thanks a lot, Ray. All right. So let's get started. As Ray mentioned, so my name is Tridivesh Jaina. I am an analytics scientist at Zementis, and this talk is, well, that's a strange noise I just heard. Okay, this talk is going to be about a new R package that is called pmmlTransformations, and I'm going to just go over the functions implemented in it and what and why you can use it. I'll mention this again later, but you can see my email, tridivesh@zementis.com, and you can email me with any questions, suggestions, etc. on that email. All right, so let's get started. For any reason, if you want me to pause, Ray, just feel free to just let me know.
Sure.
All right, thanks. All right, so let's get started, which will take a little bit of time here. All right, there you go. Sorry. All right, so here's a quick outline of the talk. So as I said, about the R transformations package maintained by us, Zementis. So real quick, I'll just mention who we are, what we do, and as the name indicates, of the package PMML Transformations, the package is closely related to the PMML package. So I'm going to quickly go over what is PMML. And finally, it's an R package. So just to be complete, even though I'm sure everyone here knows what R is, just to be complete, I'll mention R and the PMML package of R. And then finally, we get to the main story, which is the PMML Transformations package. So I'm going to go over that. And then at the end, of course, in the conclusion, I'll be happy to answer any questions you might have. All right, so as I said, let's get started with who we are. Um, we are Zementis. Um, as a company, we are devoted to predictive analytics. We were founded in 2004. We have offices in San Diego and Hong Kong. And basically, we concentrate on solving the IT deployment and integration challenge. I'll mention that a little bit in the next slide also. So we focus on the open standards, that's PMML,
Oh, Tridi, we just
and
got a question
we
from the
are,
audience. Can you just move the mic away from your mouth
uh,
a tiny bit?
okay,
Just slightly move it away from your mouth.
okay, how
That
about
sounds
the,
great.
all right, sorry about that. Okay, so let's keep going. Sorry about the mic problem there. So as I was saying, we're part of the data mining group. This is the group which maintains and the PML language definition itself. And you can see from the bottom of the screen the partners we work with. So, NIME, Adiza, and recently FICO. So it's a pretty big group which uses PMML. All right, so as I mentioned, I'm going to talk real quick about PML and interoperability. So the idea is PMML is a standard. So we have all this model building software, which you see on the left-hand side of the screen, FICO Model Builder, NIME, SPSS. And the idea is you can use your favorite software to make your models. And if there's a standard, such as PMML, you can output it in that language, and it's a standard, so you can deploy it in minutes. It really takes no time. It's ready. And you deploy it, and then you can use it to score any new data in your deployment platform. And of course, the best one is ADAPAs. So you can do real-time scoring in the ADAPA decisioning engine. That's the product of Zementis, or the universal PML plugin, which is for directly from databases. You can use Hadoop with that. All right, so after that, let's move on to a quick overview of PMML. So it stands for Predictive Model Markup Language. It's an XML-based language, which is used to define data mining models, and it's a standard, so it's used to share between all compliant applications. It's a mature standard. It's developed by the DMG, the Data Mining Group, and it's a big group, so it avoids proprietary issues and incompatibilities. And yet again, being a standard, it eliminates any need for custom deployment, and it ensures reliability. So PML defines the complete modeling process. So it's not just the direct model itself. It also includes any required information on data handling, data pre-processing, and data post-processing. So it's the entire process. Having said that, I'll be using part of it later, so let me go over the main parts of PMML. A PMML model, as I said, includes the whole modeling process information on it. So on the right-hand side, you see a basic schema of the model. You start the model, and you have a data dictionary, which defines all the raw data fields. So the input variable names, so it lets you know what you expect as the input. There's information on possible data transformations, which is required for extraction of features from raw data. And you can have that either in the top level in transformations dictionary or inside the model element itself. If you can see towards the bottom in the blue box, local transformations. So after the processing information there, you have the model itself, the model element you can see, and it obviously includes the model, and it also includes any information about post-processing of results in the outputs part. All right, so for showcasing the functions in this package, the PMML Transformations package, I will be using basically a very simple modeling example. The idea is not the model itself, but the pre-processing procedure. So it's a simple model, and I'll be using a simple enough data set, in my case the iris data set. Sure, everyone uses R, knows about it as part of the base package. And just to be complete, a real description is you have 4 continuous inputs, which is you can speedle width, sepal length, sepal width, and 1 categorical variable class. And the idea is these are the measurements of the leaves of a plant, iris plant, and from that measurement, you can use it directly or try to relate it to the class of the plant. So, okay, I'm sorry, I was just hearing some strange noises there. It's gone. Excellent. So here's the iris data set, and just an example to compare with later. I made a simple model, a regression model. There's no transformations involved here. And just to show you what you would expect to compare with later, well, here's the PML model. At the top is the header, the first box, and that's just information about the model, the user, the time, all that stuff. As I mentioned, the data dictionary is next. That's the variables expected, and then that's the model itself. In this information, in the model here, you can see the model name, the mining schema, which tells you what variables to expect and how to handle them. It's not part of this model right here, but you can have information on, for example, at least here you can see the usage type information. And then, the model itself, regression table. So just a quick, simple example we will compare to later with the transformation information. All right, so mentioned, let me quickly go through the PMML package of R. Well, there is a PML package in R, and we can output various models, and most common models, in the PML language. So I show some examples here. Support vector machines can be made with the KSVM function, and once you make the model, you can use the PML function from the PML package to output the model in the PMML language. So the step is, for example, the next one, you take make the neural network with the right package, the NNet, and then you use the PML function to output that model in PML. So here are some of the example models which can be, once you make it in the appropriate package, output in the PML language. So you can see support vector machines, neural network, trees, regression, clustering model, association rules. And some more have been added recently. General regression and a more recent one is random forest, which is pretty popular. Excuse me. And the blue color blob indicates, as it says, it's not there yet, but it's ready. It's going to come out in the next version in 9 days support. All right, so that was the PMML package. So this talk is the PMML transformations package. Here it is. The chart on the bottom shows you the idea we have about how to use it. So traditionally, you have the raw data, as you can see in the left, and you would use it, in this case, directly in the model. That's the next green one. You make your model, and then you pass on the model to the PML package, and the right, and output the PML file. The idea now is between the raw data and model, as you can see, you can use the PMML Transformations package. So now if you want, you can add the extra steps. So you take the raw data, pass it on to the transformations package, and you transform the data any way you want. And by any way, for now, in the first version, you can do things like, as indicated, min-max, which is really a linear transformation, z-score normalization, discretization, mapping, demification, things like that, and then read that transform data into your model and use those, and then output the PML version of the model, which will now include this transformation information. All right, so again, for this version, these are the transformation functions included right now. So the min-max transform, I'm going to go through these a little bit more detail right after this. The min-max transform is really a continuous normalization, a linear transformation. Norm-discrete transform is what I referred to as demification earlier. It's basically taking a string variable, let's say, and representing it in terms of 0 and 1, numeric ones. And I will explain a little bit more detail later. Map transform, well, it's a mapping, so it's one value to another, no problem. Discretize is basically, you can call it binning. You take a continuous variable and you break it up into chunks. So certain range of the continuous variable will be essentially mapped to one discrete one. Again, I'll go through this in a little more detail soon. And finally, we have implemented a z-score transform. Just because it's so popular, it's just another form of a linear transformation. And it's most frequently used when the modeler prefers to refer to the data as if it's a, excuse me, a Gaussian distributed data. All right, so let's start with the first transformation function, min-max transform. It's a linear transform, and it's referred to as min-max because there are many ways to define a linear transform, and the way we have chosen, at least in this version, is to define a wished for minimum and maximum of the transformed variable. So that's, the input variable may have a minimum maximum of 1 to 2, and we want to transform it so that the transform variable has a minimum and maximum of 2 to 3. That's one way to define a linear transformation, because you go from the initial range to the final range with a linear interpolation. So that's just the way you refer to the transformation. So Being the first function I'm talking about, let me go through the steps in a little detail. As I'm sure you know, to use an R, you have to first load the libraries. And since all the examples I'll be showing will also include the PMML function output, I'm going to first load the PMML library. You can see that in the first line, library PMML. And then, of course, you have to load the pmmlTransformations library. And as I mentioned, just to showcase the capabilities, I'll be making a simple model with the iris dataset. It's part of the base package, so you can just type iris and see it. So to do the transformations now, this is the common step you'll take always. You would use the wrap data function. You can see that iris box is assigned a value given by wrap data of the raw data, which is iris 2 in this case. So you want to wrap the data, the raw data, and make a transformation object, which will be storing all the information about the transformation. So you take the raw data, an array of numbers, and you put it in a transformation object. So iris box is what is called here. And the next line is the command for the Min MaxXform. The format is, as you can see, you pass as input the transformation object, iris box. The second one is the information on the transformation. I'll go through that in just a second. And you're also allowed to define how to handle missing values in this transformation. So map missing to 0.5 means if the input value, in this case sepal.width, is missing, the derived field is to be given a value of 0.5. So why is the input field sepal.width? Well, that's the second parameter, the information I talked about. And the format is input or raw variable goes to the derived variable and with the new range given next to it. In this case, that means the input raw data is the variable sepal.width, and we wish to transform it to a new variable. Here you can see DSW, derived sepal width for, and we want the DSW variable to have the range from 2 to 3. That's the numbers in square brackets next to it. So the square just means closed interval. You could have a parenthesis implying open interval. So that's the function, the format of the function. And to use that, I made up a simple model, so a linear regression model. So that's the next line. LM is the function for the linear regression, and I want to make the model, and to make the model you have to indicate which data you want to use. Iris box is the transformation object. To get the data is stored as the data attribute of the object. So to make any model, in this case the linear regression model, the data has to be given in this format, the transformation object iris box $data, because that's the data. And the data attribute holds the data. There's a attribute called field data, which has information on the variables. That's shown in the next box. So the transformation object iris box has field data. I show some of them. So you can see the input variables, sepal length, sepal width, petal length, petal width, and you can see the way we store the information. The data type is the original data. Whereas DSW at the bottom, you can see we store the information that it's the derived field, and the column, third column, the orig field name, lets us know it's derived from sepalWidth. And we also store the information on missing value. That's the last column. So that's to showcase the function and how we store the information on the transformation. And to showcase the effect, here's the simple regression model we would have made. The command you can see in the top is the standard PML command, PMML R model. R model you see is the name of the model we made, the last line of the top box. And there's the model. The thing to see is that the mining field in the mining schema has a field called DSW. And the regression model, a regression table in the regression model, the last numeric predictor in the table is DSW. What this means is the model expects DSW as an input. It's the raw, it's like in raw data. So whoever wants to use the model, they have to themselves calculate DSW first and then pass that to this model. With the transformation information, the command becomes, you see in the top, PML, the model name, and now you have the extra information, transforms equals the transformation object, in this case iris box. And the difference is, if you see the mining schema no longer has DSW. That's not a raw data. That's a derived data. So it's not an expected input. It's not there. There is a new element you didn't see before, local transformations. You notice after output, not much there. And that defines a new derived field, DSW. So you can see it's a derived field named DSW, and it's derived from sepalWidth. And then the regression table can use the DSW. And the whole idea is DSW now isn't required as raw data. As the user, you do not have to calculate it before you call the model. It's all done for you inside the model. So you can just take the raw data, apply the model, and score it. There's no extra steps required. All the information is in the model. And that's the whole idea here, that the whole modeling process is information is now stored. So I went through this in detail because the first function you talked about. The basic idea is similar, so don't worry, from now on it won't be that detailed. The next function I want to talk about is discretization. It's sort of like bucketing the values. So here's a pictorial representation of what I mean. So on the left, you have a continuous variable, this continuous, and I have, in this case, excuse me, divided it up or binned it into 3 categories, A, B, C. And the idea is if the continuous variable has value in a certain range, let's say the top part here, it's discretized into the value, categorical value A. So, and same for B and C. So basically, a given range of the continuous variable is now referred to as one categorical variable. That's discretization. And here I showed the command. Just like last time, first you use wrap data to make the transformation object. And the command for discretize is, well, discretize. The first input parameter is the same, the transformation object, iris box. Then the information on the transformation, I'll go through that in a second. And we need a table, an external table in this case. I'll talk about that too. And like last time, you have the option of providing a missing, what to do if the value is missing. What's the value to give to the derived field? All right, the transformation information is you basically are telling the function what is the original field and what is the derived field name. So here you can see that the first information tells us that you want to discretize the input variable sepal.length and call the transform variable DSL. So you go from sepal.length to DSL, and bucketing be a can be a bunch of possible data types. So we have to tell the function the data types. So here we're saying we want to go from double to string. So sepal.length is a double variable of data type double. Is a double number, and DSL we want to be a string. And how exactly do we discretize it? Well, that's the information in the external table. In this example, intervals.csv, and what that would look like you see in the bottom. And the information is data range, comma, discretized value. So the first one says, well, the left isn't given, the left interval, so it's basically negative infinity. And 5 with square brackets means a closed endpoint 5. So if the value is between negative infinity and less than equal to 5, we want DSL to be given the string value val1. If sepal.length is greater than 5, square parenthesis, or less than equal to 6, that's the second line, we want DSL to be given the string value 22, and so on. So like last time, once we do it, I show the data field this time, and you can see there's a fifth data column, DSL, in the data attribute, and here are the new values, and you can see that, for example, the first line, sepal.length is 4.6. 4.6 is between minus infinite and 5. So correctly, it is given the string value val1, and so on. All right, so that's discretized. Here's the next function, norm discrete. I refer to this as termification of variables. The idea is, given a discrete variable, you want to refer to it as a numeric fashion. So what this means is we define another variable, the transform variable, and you define it so that if the discrete variable has a certain category, which you define, then the derived field has value 1, otherwise it's 0. So for the iris data set, as we know, the species variable has 3 possible categories. Iris setosa is one of them. So we can define a transform variable, which is the norm discrete transformation of species, so that if species equals setosa, the transform variable is 1, otherwise it's 0. And here's how you do it. Again, first you wrap the data, make the transformation object. The format for this function is simple. You just say norm discrete transform, the transform object iris box, and the discrete variable you want to apply this function to. So we say species, um, what this will do is find all possible categories of the raw data species, and for each one make a derived field. So so you can see once you use the function, um, since species has 3 categories, you can see 3 new variables. Automatically they're called species underscore first variable setosa, species underscore versicolor, and so on. And species setosa is, you can see, defined as if species equals setosa, it's 1, otherwise it'll be 0. So the first 2 rows, it's 1 because species is setosa, and from then on it's 0. For example, the third row is species is versicolor, so species setosa should be 0, and it is. So the derived variable um, the idea is the same for the other 2 categories. And this time, let's show what would happen and how the PML would look. So at the top, again, we make a simple regression model. And to output the PML, again, the command is PML, the model, and transforms equals the transformation object. And you can see the part of the sample PML that the raw data expected in mining schema is the raw data, sepal length, pedal width, and species. There's no extra variables. All the transformation information is encoded in the PML model in the local transformations element right below it. And PML defines it as a norm discrete element. You can see its derived field is called species setosa, and this derived field is defined as the norm discrete field. And in PML, that's defined as, the field is species. If it's equal to setosa, then it's 1, otherwise 0, as we expect. So here's how the PML would look. And again, the whole idea is, as a user, you don't have to do all this before you call the model. You still use the raw data, no extra work required, and all the transformation work is done by the PML model, defined in the PML model. All right, the next one is the map transform. It's pretty intuitive. You map values from one to another. Okay, so in this example, to show the format, I transform the value species to another derived field and dspecies, and here's the information how you give it to the map transform function. So by the way, first, as usual, you use the wrap data function, make the transformation object. Then you call the map transform function, and as always, the first parameter is the transformation object, RSBox. The transformation information is next. I'll come to that. And the information on the mapping is in the external file, given as the third parameter, and as usually allowed to indicate how you want to handle missing values. So the information transform info is same format. You're saying, as you can see here, you want to transform the raw variable species to a derived variable dspecies, and you are going from a variable of type string to a variable of type integer. Species is string, dspecies is integer. And the exact mapping is in this external file, mapspecies.csv, and at the very top you can see what that would look like. So for example, setosa comma 2 means, well, input variable, if its value is setosa, it's mapped to the value 2, and so on. And again, the data field I show at the bottom, shows after the transformation what it looks like. As expected, there is a sixth column with the derived field D species, and the first two rows, Setosa, is mapped to 2 as expected. Let's go to versicolor. You can see from the top map species.csv, we wanted it mapped to 4, and well, it is. So yeah, great, it works. And here's what the PML, for example, would look like. Command again at the top, you can see is PML, model name, and then transforms equals a transformation object. And in PML, the mapping is defined as a map values element. And the aim here isn't so much to talk about PML itself, so I won't go through the details, but the idea again to show you is that the information is encoded inside the PML model. You don't have to, the transformation will be done automatically when the model is processed. All right, and the last one is a special function as ZScore. It's a special case of a continuous normalization. And just made up a special case. You could have done this through a linear transformation directly, but this is so common enough that maybe a specific special function would be useful. So Z-score transform basically means given a data, we find the mean of the data range, and for each particular value of a data, we want to express it as its distance from the mean in units of the standard deviation of the data distribution. So the command is simple enough. You can see first you wrap the data as usual. And the command is ZScoreXform with the parameters that transform object, and the transform information in this case I've shown is column 2 to DSL. The format here shows column 2, which is the second column of the data, which is sepal width. So we're saying we want to apply the z-score transformation to sepal width variable, and we want to call the derived field DSL. This is a common feature applicable to all functions. You can refer to the variables either by the name or the column number in the input data. So beetle.length is beetle.length, or it's column 3. And this is true for all cases I've talked about. So here's the PML. The format is again PML model, comma, parameter transforms equals a transformation object. And as I said, this is a special case of a linear transformation, and so the way it shows up in local transformations is a linear norm inside a linear norm element, which is part of the norm continuous element. So it's a special case of a linear transformation, and that's how it'll show up. All right, so those were a quick summary of the functions available to you. I want to sort of emphasize here, this is linked closely to the PML package, which is why I kept showing all the output PML. But the transformed data can also be accessed directly by you for any other purpose. So as I showed, the data is available in the data attribute of the transformed object. So you can use it directly to make your PML model, or you may, if you want, you may also just access the transformed data values by using the data attribute. So transform object $data will give you access to the transformed data also. So it can be useful not just for PML, but for your own use. So just use it to transform the data and get the transformed data values. So quickly then, the conclusion I would then say is, while the data pre-processing is frequently required, and this package PMML Transformations offers the capability to transform the data with some common functions and include the transformation information if you make a model with the transformed data in the output PML model with the whole all the information in there. And so with that, I will conclude. Thank you very much for spending some time listening to me, and I'll be happy to take any questions. And real quick, Ray, can I again add, if you have any criticisms or any suggestions for me to change or add to this package, feel free to contact me. You can, okay, I'm very sorry. I made a big mistake.
That's all right. You can just put up your slides again.
There you go. Yeah, I was just trying to go to the very top, which is a very inefficient way. And there's my email at the bottom. So any questions, criticisms, and suggestions, feel free. You can find my name directly from Zementis.com, or if you remember, write it down, or any other way. You can send me feedbacks on my email. That's Tridivesh. You can see at the bottom, tridivesh.jena@zementis.com. Okay, thank you very much. And any questions, I'll be happy to take them now.
Yes, thank you, Tridi, for that wonderful webinar on PMML transformations. And we're going to open up for questions now. So if you look at your GoToWebinar control panel, you'll see an orange button with an arrow either pointing to the right or pointing to the left. And if you click that orange button, it will maximize and minimize your control panel in a toggle-like fashion. And once it's maximized, there's a section in the control panel called questions, and you can send questions to the panelists today, and they will be answered. So we have about 12 minutes left before the end of the webinar time slot. So we can answer any questions you have. Go ahead and send them through, and we'll answer them in a queue fashion. So I have some questions here that Tridi can answer. So you mentioned that discretized transformation is not available. When will it be made available?
Yes, so it is ready, but yeah, it'll be available in the next release of the PML Transformations package.
Mm-hmm.
It will include that and hopefully some other extra improvements in the already existing functions. So it'll be available in the next release, which I can't give an exact date, but I think it'll be very soon,
Okay.
next month or so.
And then here's a question. Is the webinar being recorded? Yes, the webinar is being recorded, and you'll get an automatic email from the GoToWebinar software sometime today, within the next 2 to 3 hours from now, with a link. And the webinar video and slides should be posted within the next 5 to 7 days. So please be patient with that. And I have another question. Can all models be exported to PMML?
From R, let me show you. It's here you go. Here's a list of the models which can be, as of now, exported from R in PML language. Three quick points. The first is, well, the naive Bayes models you see at the bottom. You can't do that at the present version of the PML package, but it's ready and it'll be coming out with the next release. Um, as for the others, if you remember in R, it's not just the model, it's which package. So if you use the right package, these are the models which can be supported. And I think if you look at it, these are almost all the major models.
Yeah.
So random forest, you have to use the random forest package and it's supported, and so on. Neural network, yes, you'll have to use the network package and net. Um, but if you do, yes, neural network is supported. And if you look at it, almost, I believe personally, all the main, most important models are exportable.
Okay. So another question here. Are you going to be at KDD conference? I heard there will be a PMML workshop during the conference.
Um, yes, we will indeed be there at the KDD conference. Um, yes, there is going to be um, a presentation on PMML, and I would encourage you to go. Face to face is also pretty good and useful, and you can ask any other questions you have, and you have hopefully in the meantime. So yes, please do.
Sure.
If you do come to KDD, visit us there.
And can you talk about the roadmap? I have a question about the roadmap of PMML transforms and PMML core package as well. Things that are scheduled to come, say, within the next 6 months or so.
Yes, so let's start with the PMML transforms package. Here you go. Um, so the roadmap is well threefold. Uh, the next version, as I said, will be adding the discretization function, and part of the roadmap then is to get feedback from users, find the most popular or desired transformation functions which people use, and make sure they are included. So these are what we came up with as some of the popular ones. But if there's others which you use and you don't see it, yes, definitely give us some feedback, let us know, and we will make sure to add. The aim is to eventually have all the possible popular transformations here. And the second is even the ones which are included, we can always extend them to make it more and more general. That's going to be also a major part of the roadmap. Um, so, for example, um, you know, I'm just trying to think of one I was thinking about. Um, I've shown you an example of a mapping from one to another. Um, we have one-to-many mappings possible. We have many-to-one mappings. Um, it'd be nice to include, as that'll be extension of the mechanism, and we'll be adding those capabilities also. Um, I believe we have the main ones. Extension and adding of new functions are the main parts of the roadmap of the package.
Okay.
Um, if I quickly add, because I went too long here anyway, but the PML package, I should add same idea. I believe we have most of the main models covered, but we'll keep an eye on the popularity of different models, and if that people start using, people desire new models which are not included, we will certainly do our best to include that. So again, feedback is very important. Please do feel free to contact us with any feedback. Thank you.
Sure.
Sorry, go ahead.
Okay, so how can a person uh, get around coding PMML transformations that are not yet part of the PMML transformations R package? Do you have some type of tool that can assist with this.
Okay, so I think I understand the question as uh, you yourself want to add or modify the to the PML transformations package. Well, as in any R package, it's available to you, open source. As the maintainer, all you would have to do is make your modifications, additions, send them to me. I'll just run a quick test to make sure it works as expected, and include that in the next release. As to the question about how to modify it, um, it's an R code. You can use your favorite modeling techniques to modify it. As with most of R, I think almost all of it is knowledge of R code, and you just use your knowledge to add your own coding. I'm not sure exactly what you mean by any help. Just like any other
Oh, like
language.
maybe a transformations generator.
Oh, that, yeah. If you go, there is a transformations generator available. If you go to the Zementis web page, I believe you will see a link to PML. Um,
And we
I
can
forget
provide that link.
exactly.
We
Yeah,
can provide that link to anybody who's interested. Just email the automatic email that you'll get within the next 2 to 3 hours from GoToWebinar requesting that information, and we can respond to you with the link to the transformations generator.
yeah, that'll be yeah, that'll be ideal. I don't remember the exact link, but yeah, there is something for you to
Okay.
use there.
And here's one about Adapa, which is the product that Zementis makes. I know Adapa uses PMML as a solution for deployment of predictive models. What about business rules? So, could you comment on the business rules aspect of Adapa?
Um, Business rules is part of the PML schema, so you can definitely include that as part of the PML model. So um, at the end of the day, in your model, if it includes business rules, yes, Adapa can handle it. You can use Adapa to score input data, use the model, and use the score data to output to analyze the business rules part of the model and output the right business rules.
Sure. So, in your tool, Adapa, does that support frameworks like Drools, open source business rules framework?
Oh yeah, definitely. So um, I would again encourage you to get in touch with me, and I can send you a link or some documentation on um, more details on it. But the basic answer is yes, definitely.
Sure. Well, great. So we are at the end of the time slot for the webinar now. And if you have a question, you can always email it to the automatic email you'll get from GoToWebinar. And if you didn't answer your question today, just email it to us, and I'll send it over to Tridi via email. And I wanted to thank everybody for coming today. And it was a great job by Tridi of Zementis, the package maintainer for PMML Transformations. And Tridi, anything you want to add before we close down for today?
Um, no, just again, just to emphasize it, I'm going to repeat it again. Feedback is a major part of the improvement of these packages. So any ideas, suggestions, offers to, add your own code, etc. Um, let me know, and we'll work with you. I hope you have my email. I guess it'll be part of the our posting, maybe, Ray?
Yeah,
Uh,
we'll go ahead, and if you have any questions, just respond to the automatic email you'll be getting from GoToWebinar, and then we can forward those to Tritty, and we're going to post the video and the slides within the next 5 to 7 days. So be patient for that, and we'll get that posted up. And and that's it for today. So we'll go ahead and shut down the webinar. Thank you everybody for coming, and hope to see you soon at a future webinar. Take care. Have a great day, great afternoon, or great evening wherever you are in the world. Take care.
all right. Thank you, everyone. Thanks, Ray.